So welcome to this video. In this video I am going to explain some problems in Cauchy's integral formula. The problem is, if pi of a is integral over c 3z square plus 7z plus 1 divided by z minus a dz, where c is the closed circle modulus z equal to 2. So find pi of 3, second one is phi dash of 1 minus I, third one is phi double dash of 1 minus I. So solution. So in this problem, now I am going to apply Cauchy's integral formula. So before that, I am going to replace a by 3 1 minus I. So from that I will get the answer for this question. Right. So here, by using, we know that Cauchy's integral formula, integral over c f of z divided by z minus a dz equal to 2 pi I into f of a. So this is the statement of Cauchy's integral formula, right? So if you want to use this formula, so the point A should lies inside C, inside closed curve C. Suppose the point A lies outside C, that value is going to be 0. That value is going to be 0 by using Cauchy's theorem, right? So here, if you want to find this value, we want to take A as 3, right? So now I am going to do first subdivision. So here I am going to take f of z is nothing but 3z square plus 7z plus 1. Here I am going to take a equal to 3. A equal to 3. So now I am going to draw a corresponding closed circle. The image of this circle is, the center is 0, 0, radius is 2. So like this I am going to draw the circle of radius 2, right? This is C follows counterclockwise direction, right? So here try to mark this point in the complex plane. So z a equal to 3 is nothing but z equal to 3. So how to represent z equal to 3 in a complex plane? Simply try to identify what is real part and imaginary part. So you can fix that point by using real and imaginary part. So here real is 3, imaginary point, there is no imaginary point, you can take 0. So by using real and imaginary point of this value, you may get 3, 0. So 3, 0 lies here, right? So from that you conclude a equal to 3 lies outside the given closed circle, right? So by using, so here since a equal to 3 lies outside C, so therefore by Cauchy's theorem, integral over C f of z minus a equal to 0. So this value is nothing but pi of a. So already we have taken a is 3. So you can substitute, you may get pi of 3 equal to integral over C f of z minus 3 dz equal to 0. So this is the answer for first one, right? Next one is I am going to find 1 minus I. So I am going to erase this space. Subdivision 2. So in this part I am going to take A is 1 minus I. 1 minus I. So if you plot this point in the corresponding curve, so you can plot 1 minus I as 1 comma minus 1. 1 comma minus 1. So this radius is 2. So 1 comma minus 1 lies in, suppose if you take 1, you may get that point lies inside the circle, right? Lies inside the circle. It belongs to here, right? Or without using the corresponding image, how to identify this point lies inside the closed circle modulus z equal to how? It is so simple. So what is given? Modulus z equal to 2 is given. So better, instead of z, try to substitute 1 minus I in the left hand side. What will happen? What is the value of left hand side? That left hand side less than right hand side means you can say that particular point lies inside the circle. Suppose that modulus lies, that means that modulus is greater than 2 means that point lies outside the closed circle. Simply you can identify without using that image, right? So suppose if you substitute 1 minus I, so already you know the formula how to find out modulus, right? So simply you can find out real part square plus imaginary part square. So simply you may get 1 plus 1, which is equal to root 2. The root 2 is nothing but the approximate value of root 2 is 1.41 something, right? So which is less than 2. So from that you can identify this value lies inside C, right? Now by using Cauchy's integral formula, Cauchy's integral formula, you can get, already we have taken phi of A is integral over C f of z minus A dz equal to 2 pi I into f of A. 2 pi I into f of A, right? So here already you know f of z is 3z square plus 7z plus 1. You can substitute, you can replace z by A, you may get the value f of A. Try to substitute. So you can equate phi of A equal to 2 pi I into 3a square plus 7a plus 1, right? So it is pi of A. Our aim is we want to find pi dash of A. So before substituting 1 minus I, try to find out two derivatives, successive derivative of phi dash of A, pi of A. That means try to differentiate this expression with respect to A twice. So from that you may get pi dash of A and phi double dash of A. So from that you can get the answers for pi dash of 1 minus I and pi double dash of 1 minus I, right? So now with the help of this expression I am going to find phi dash of A. Phi dash of A is nothing but I am going to differentiate with respect to A. If you differentiate, you may get 6A plus 7. Again, try to substitute. If you differentiate again, you may get 2 pi I 6, right? So from that you may get pi dash of 1 minus I equal to 2 pi I 6 into 1 minus I plus 7, which is equal to equal to 6 minus 6I plus 7, 2 pi I 13 minus 6I. If you multiply I inside the close bracket, you may get 2 pi I 13I minus 6I square, which is equal to 2 pi 13I plus 6. I square is nothing but minus 1. So I have replaced I square by minus 1, you may get plus 6. So from that you may get pi dash of 1 minus I. Similarly, by using second derivative, I am going to get 1 minus I equal to, the right hand side it contain A is not coming. So if you substitute anything, you may get the same value. So simply you may get 12 pi I. This is the answer for second one, right? So in this problem, try to identify whether the given singular point lies inside the closed circle or not, or closed curve or not. Suppose lies outside means directly you can substitute, it is a 0. That integral, it is going to be 0, right? So next one, next problem. Second problem, evaluate integral over C sin pi z square plus cos pi z square divided by z minus 1, z minus 2 dz, where C is a closed circle, modulus z equal to 3, right? Solution. Right. So here also I am going to use same formula, Cauchy's integral formula. So before that, where the integrand fails to analytic, or where the function is not defined, which point the function is not defined. Simple. Suppose if you substitute z equal to 1, you won't get anything, right? So for that, if you equating the denominator equal to 0, you may get 2 points. I think z equal to 1 and z equal to 2. Of both point, the function is not defined. So at a point, the function is not analytic, right? With the help of, with respect to that point, I am going to apply Cauchy's integral formula. And also you can check whether these both formal term, both point lies inside this curve. You have to use partial fraction, because this problem contained product of two factor. In problems, in a statement of the Cauchy's integral formula, only we have seen in denominator only one factor is coming, but here it contains two factor. Both factor, that means both elements of this factor lies inside the closed circle. So for that, I am going to split the integration into two parts, right? After that, I am going to apply Cauchy's integral formula. So for that purpose, I am going to apply partial fraction, right? So keep in mind why we are using partial fraction is most important, because in this problem 2 points are singular points. These both 2 points that means lies inside the circle, right? That's why I am going to apply partial fraction, right? Suppose one point lies inside the closed circle, another one is lies outside, means no need to apply partial fraction, right? So both points lies inside the closed circle, that's why I am going to apply partial fraction. It's most important, right? So simple. It is suppose if you draw this closed circle, the center is 0, 0, radius is 3. So for that, I am going to draw the circle of radius 3. So if you equating this term equal to 0, you may get z minus 1, z minus 2 equal to 0. You may get z equal to 1 and z equal to 2. Right? Z equal to 1 is nothing but 1, 0 lies inside the closed circle. Z equal to 2 means 2, 0 lies inside the closed circle. So these 2 points lies inside the closed circle. That's why I am going to apply, before substituting Cauchy's integral formula, I am going to use partial fraction, right? So since z equal to 1 lies inside C, z equal to 2 lies inside C, right? So now I am going to consider 1 by z minus 1, z minus 2. I am going to take z minus 1 b by z minus 2. So if you want to find a, you can take from the given function 1 by z minus 2, except this factor, you have to take the remaining terms. In the left hand side, you have to substitute the left hand side terms except this factor, right? After that, the what value of z, that term is going to be 0. So that value you have to substitute inside the terms, right? So for that, suppose if you substitute z equal to 1, you may get 0. So that term I am going to substitute in the closed bracket, right? If you substitute, you may get the value of a minus 1. Similarly, you can find b equal to, similarly same idea I am going to find b. Except z minus 2, I am going to substitute remaining terms. So 1 by z minus 1. If you substitute z equal to 2, you may get that term is going to be 0. So for that, I am going to substitute z equal to 2 in the closed bracket. So from that, if you substitute, you may get b equal to 1. So now, by using the assumption, I am going to write z minus 1, z minus 2 equal to minus 1 by z minus 1 plus 1 by z minus 2. So here most of the case I am going to take the numerator as f of z. Here also, by using the previous example, here also I am going to take the numerator as f of z. So here I am going to take f of z is nothing but sin pi z square plus cos pi z square. So now I am going to multiply f of z on both sides in this last expression. So from that I may get f of z minus 1, z minus 2 equal to minus f of z minus 1 plus f of z minus 2, right? So now I am going to include the integration with respect to z on both sides. So from that you may get sum of two integration which have unique factor. So from that definitely you can apply Cauchy's integral formula in each case uniquely. Right? So if you include the integration, you may get f of z minus 1, z minus 2, dz equal to minus integral over c f of z minus 1 dz plus integral over c f of z minus 2 dz. Now by using Cauchy's integral formula, you may get minus 2 pi I into f of 1, because the one term singular point z equal to 1 lies inside C. That's why I have put into f of 1. Suppose that point 1 lies outside C, the term automatically it is going to be 0 plus 2 pi I into f of 2. By using f of z, try to substitute f of 1 and f of 2 here. So from that you may get, if you substitute z equal to 1, you may get sin pi plus cos pi plus 2 pi I sin 4 pi plus cos 4 pi. So already you know the result. Sin n pi equal to 0, cos n pi equal to minus 1 power n. Try to use this formula here. So from that you may get minus 2 pi I, so 0 minus 1 plus 2 pi I, 0 plus 1. So if you multiply you may get 2 pi I plus 2 pi I equal to 4 pi